Time to do some science experiments. Just make sure I got this flask set up appropriately. We'll add a little drop of sodium hydroxide over here on the left. Oh yeah, we're seeing some color changes. Sure enough, looking like a little rainbow right off the start. Haha, nice and beautiful. Nice and beautiful. Let's chase that with some hydrochloric acid. Little drop there. Yeah, that's nice. 2 drops there. Hey, Arjun. Welcome aboard. Science is definitely the best. I'm just making sure I've got this flask over here on the left set up okay. Hey, Oren, how are ya? Me too, Mexican. I love some chemistry. What's everyone been doing this week? Anybody getting any studying done? There we go. Another drop of hydrochloric acid. Another drop. Oh, look at that gorgeous color. I'm going to focus on this one just a bit. Got some really nice colors going on today in here. Just trying to get a feel for how the indicator is behaving today. 2 drops of acid there. Yeah, folks, what is the best chemical you like in the periodic table? Mexican Dirt wants to know. Y'all know my favorite, hydrogen. Look at that gorgeous rainbow tornado. Yeah, drop the element symbol of your favorite element in the periodic table right in the chat. There's a couple drops. That's right, Kino, we mean element. What's your favorite element? I'm a hydrogen guy. I like to keep it simple. Thank you there, Oren. Let's do a couple drops of hydrochloric acid. Gold! I'm loving some gold. I love gold. All right, another drop of hydrochloric acid. Let's see what happens. Look at those beautiful color changes. It's like a rainbow tornado, isn't it? I'll turn that other stir bar off. It's making a bunch of racket. We'll chase this with a drop of sodium hydroxide base. Carbon. So the organic chemist has entered the chat. Kino. Cesium is definitely an element, Mexican. It's one of the alkali metals. Hello, Stickmans. Catenation. Come on, Kino. Remind me what catenation means again. I have forgotten. Hey, Oren, how are you? I'm embarrassed to say because I'm a chemist, but I have forgotten what catenation means. So please remind me. It's not a term I've used often. Hello, Daniel. Come on, Kino. Let's educate everybody. Hello, MLG. Tell us what catenation means. I think it means that you're adding a bunch of carbon atoms together. That's my guess, but I think I've forgotten. Hello, Dolan. Hello, Z. Oh, man, we got some beautiful colors happening here today. All I'm doing, folks, if you haven't seen the live before, I have a flask here with some universal indicator in it. There we go. Carbon has the ability to form long chains, so I was right. The property of catenation. Thank you for reminding me of that. Yeah, we're just chatting about science. We're chatting about chemistry. We're chatting about life. What I have here in this flask is some water. Thank you, Mexican. I appreciate that. It looks like it, mister, but this is actually a chemistry experiment. I've got some universal indicator. It's also known as rainbow indicator in this flask. Thank you there, Amanda. And rainbow indicator displays different colors at different pH values. Here are the different values that you will see. So yeah, right now, there's a whole bunch of different colors. So there's a whole bunch of different pH values in the flask. Up here at the top, it's green, and that tells us up there it's neutral, pH 7. Yeah, this is science. It's like science and art together. Right now, it's homogenized. The mixture is homogenized at like a yellow color, which is pH 6, which is slightly acidic. Now watch what happens when I add a drop of sodium hydroxide base. Here it goes. 1 drop. And we get a violet color right away. So our pH is way up there at pH 10. Very basic. Very basic. Now I'm going to neutralize the base, thank you there, Amanda, by adding a little bit of acid. The acid I add is hydrochloric acid. It's just that this stuff is like 100 to 1,000 times more concentrated than what's in your stomach. The most acidic solution that I have personally used is probably concentrated sulfuric acid. Oh, wow, MLG, I hope you're okay. Hope you're okay. Nice, Sonny Cat. Are you a chemistry teacher? You got it, Kino. You got it. Thank you there, Amanda, for the vote of confidence. I think a little later, if we get roughly 100 people here in the live, I think I'll repeat the experiment from the video that I did. I'm sorry to hear that, MLG. I'm giving you best wishes. So yeah, we're up over 100. So if folks want to, I can do a repeat of the video I just dropped this morning. Mexican, I do know Piranha solution. Hello there, drama. I have put a Scrub Daddy in Piranha solution. Thank you there, MLG. I wish you a quick recovery. Tell you a little bit about tap water, says Adventures. Well, tap water, it has a widely variable composition. That's the best I can tell you. Yeah, tell me about it, Just. MLG wants a shout out. MLG was in a car accident today, broke their leg, so let's all send him or her or whatever well wishes. Tell your dad I said hello to, Mr. Bulldoze, sorry. You got it, Mr. Paco. Pay attention to Mr. Paco's comment. Mr. Paco is helping folks recognize some chemical properties of both acids and bases. Amanda, my favorite color. Oh, we got drama. We got the NASA scientists here. Drama visit. We got the NASA scientists in the chat. I love it. Maisie, I don't know if I'm going to make any bromine. Actually, I did do that in one of my lives. Not my lives, in one of my YouTube shorts. Make the Doctor Strange portal again with rust. Yeah, I might do that again this weekend. Demoni, tell your mother hello and happy Mother's Day to all the mothers in the chat. And, please send would like to send my well wishes to all the mothers in the chat. So, yeah, I just dropped a new shorts video today. Hello there, 10 Wind. I dropped a new shorts video today in which we do some experiments with two different types of water. Thank you there, Amanda, for the vote of confidence. Mexican, I can do that, but it has to arise naturally. I'd love to give you a shout out in my shorts, but it's gotta make sense. Let's just put it that way. But yeah, you guys want to see, give me a thumbs up if you'd like to see the experiment that I just dropped in my YouTube short today. Give me a thumbs up. If not, we'll keep doing this particular experiment. This is the old standby. Okay, Mr. Paco, what I am adding right now as I speak, this is going to be hydrochloric acid. So here we go. Mexican, I do one short a week. That's enough. So Drama Visit wants to see the new experiment. I'm adding hydrochloric acid to the flask right now. Maisie Boy, yeah, annoying. It looks like a rainbow. We call this rainbow indicator. And there we go. I've added enough acid that now we can start to see it's reacting with the base. It's pretty. Let me add a little bit more. Thank you there, Andrew. Oh, what's this? Chris. You got it, man. Happy birthday, Nick. Happy birthday, Nick. Chris, you're gone, buddy. You almost got me. Pretty close. Pretty close. What's the craziest experiment I have ever done? The craziest experiment I have ever done is probably the bucket launch. Can I please dump all the acid in? We'll do a bunch. How's that? Happy birthday, Diego. Hello, Brooklyn. Here, let's add a bunch of acid. Here we go. Big old squirt. Boom. Oh, I added base like an idiot. Sorry about that. Of course, nothing happened. Let's add a big squirt of acid here. There we go. Big old squirt. Excuse me. Too much base in there. Let's add another big old squirt of acid. See what happens. There we go. Man, there's a lot of base in there. The base is just chewing up all the acid that I add. Here we go. Boom, boom, boom. So long, Manda. Man, there's no color changes going on here. Come on, baby. Come on, we want some color changes. There we go. Man, I have a lot of base in there. It is just chewing up all the acid that I'm adding. So long, Brooklyn. Now we're getting somewhere. We are finally getting to the point. Boy, there was quite a bit of base. There we go. I finally added enough acid where the pH is dropping. Hello there, Charles. All right, let's add a drop of base now, right there in the middle. Which indicator do I use to view the color? I apologize, I don't understand the question. Maybe I do. There's like 4 different indicators in this system. How you doing there, Charles? Not a whole lot, Mexican. That's not why I do this, though. I'm not doing this for the money. I'm doing it just because it's fun. Hey, we got over 100 people here in the chat, so let's do the experiment that I dropped this morning. Okay. So what we're gonna do. We'll come back to this experiment, but what we'll do is we'll do the soap experiment that I did earlier. That I did a video on this morning. So here we go. What we're gonna do is I'm gonna take 2 different brands of water. All right, let me just zoom in on this just a little better. There we go. All right, so I'm going to use 2 different brands of water. And the 2 different brands of water I'm going to use, where is it? There it is. Oh, the Evian water. I'm not sure I'm saying it right. Evian, I don't know. Anyway, this water, you can see it says it's comes from the French Alps. So it has percolated through soil, and because of that, it picks up some. Here, let's turn this light on so we can see it. It picks up some calcium ions, and it picks up some magnesium ions. You can see right here. There's some calcium ions in the Evian water. All right, here we go. So I'm going to pour a little bit of Evian water into this flask. All right. Hello there, Khadijah. Hello there, Adiaman. And then in the other flask, I'm going to add some purified water, some distilled water, okay? A little bit here. So this is a comparison. On the right side, we have distilled water. And on the left side, we have, hello there, Johnny and Crunch. And on the left side, we have Evian. Mr. Paco, what I use is a combination of 4 different indicators for the indicator system. Okay, now that we got this set up, I am going to shave into each flask some ivory bar soap. Just a little bit, just a few pieces. So again, we've got water that contains calcium ions on the left, and we have water that's been purified, so it essentially has no ions in it on the right. All right, so here we go. Here's my ivory soap, and we're going to shave some pieces into both sides. Here we go. We're going to shave a little bit over here. That's going into the water that contains the calcium ions. And over here on this side, we're going to shave some of this ivory soap into the water that has been purified. It's about an equal amount. Okay. All right, now it's time for the experiment. I'll take my straw here, and I'm going to blow bubbles into this flask over here. Now remember, this one over here is Evian. So this one's Evian, this one's purified. Here we go. Blowing some bubbles into this water over here. I don't see a whole lot, but you might notice that the water has gotten kind of cloudy. Hello there, Donna. All right. Now we're going to try the same thing over here with the purified water, the distilled water. Do you notice the difference? Here, let's shave a little more in. Just going to shave a little more in. All right, here we go. Let's just shave a little more in. It's not quite as much as what I was expecting. I'm just going to try to get a little more shaved in here and a little more shaved in here. I'm also wondering if that might be my tap water over there on the right. That would really stink. Here we go. We'll try it again. All right. And now we're going to try the side on the left. So you should be able to see there's quite a bit more sudsing in the water on the right than there is on the left. Hello there, Damien. And that's classic results in this particular experiment. What we normally see is if water contains calcium ions, those calcium ions actually precipitate out the soap as a solid. There's some ions in the soap that dissolve. You need those dissolved to get the sudsing action. You can see it's hard to see through this because a solid has formed. On this side, the water remains transparent, so the soap ions stay dissolved in solution, and so this stuff is going to suds a little better. Hey, Maria, how are you? Please do not spam the comments or you will be blocked. There's your warning. Can I add acid? I guess we'll go back to our regular experiment. We'll start adding acid and base again. Here we go. Let's try this flask here. All right. Let's start adding acid and base. All right. That's exactly why you use water softeners. That's correct, Mr. Super. All right, here we go. Greetings from the United States. We got someone from Ecuador in the chat. All right, let's add a little bit. I'm doing well, Damien. How are you? Hello, Geiger. Here's a couple drops of base. Look at that quick color change. Now we're going to add a drop of acid. A couple drops. Get some nice color changes going on. Hello there, Ashish. There we go. Can I add acid to the soap mixture? Sure, we can do that. We sure can. That might... So if we add acid to the soap mixture, let's do that. We're going to add it to the one where the calcium precipitated out. So this is the one where the calcium precipitated out. If I add some acid to this, we may be able to dissolve the solid. So this may become less yellow. So I'm going to add a drop here and swirl. That may become less yellow if I can get I'm going to have to add a bunch. If I can get the calcium palmitate solid to dissolve. Doesn't look like it's working really well. Hey, we got someone from Somalia here. Welcome aboard. Not happen, Sonicat. Not happen. I'm not a synthetic chemist anyway. There we go. I'm adding acid to the flask. You can see flashes of different colors as the pH drops. So long, Drama. Thanks for joining in. I appreciate you being on board today. Boy, look at those gorgeous color changes. Let's add thank you there, Anita. I appreciate that. We're going to add a drop of base now. Watch the pH go up. Where I'm at, it's about 3 o'clock. Let's add about 2 drops of the acid. Very nice. So yeah, what you're seeing here is universal indicator. It's a pH indicator. It changes color depending upon pH. Right now it's like a pH of 4. That's going to be like an orange color. And if I add acid, it should drop. The pH should drop as I add acid. That's going to become like a red color. There we go. Now we're at like a pH of 3. pH of 3 or so. Now I'm going to start adding base. How about it there, Mexican? I'm going to add another drop. Here's a drop of base. And as I add drops of base, the pH should go up. Wow, man, that went from like pH 3 to pH 10. That's a huge change in pH. It is nice to see a perfect titration, but I'm sure not doing one perfect titration. All right, we got a couple drops here, a couple drops of acid. So Mexican, what if it turned red? I think I am turning it red here by adding drops of acid. Hello there, Yash. Welcome aboard. We saw a little rainbow action there, which is always fun. There we go. Let's add another drop there. See if we can get that pH down to pH 3 or so. Boop, and it go. Oh, that's a base. I'm an idiot. That's going to raise the pH. Let's add some drops of hydrochloric acid. There we go. There's one drop. There's another drop. These are the different colors that you will see depending upon pH. Here, let's put this up over here so we can see that close by. There we go. Those are your different pH values that you will see depending upon what's going on in the flask. You can see we're at a very high pH, pH 10. That's very basic. What if I had cobalt ions? If I add in cobalt ions, it's probably going to turn a, well, you're probably not going to see it real well because the indicator is so dark. So great question, John Doe. Why does it start from the bottom and work its way up to the top instead of reverse? Mr. Paco, I don't have the whole scale because the color is red at pH 3 and below, and the color is violet at pH 10 and above. So John Doe, why does it start at the bottom? Let's talk about this. So you can see right now, and I'm going to turn the speed way down so you can get an idea, all right, of what I'm talking about. Now, you'll notice there's a vortex going on in here, and just like the eye of a hurricane is low pressure, the eye of our vortex is also low pressure. And you should recognize that material moves from high pressure, so that's going to be the outside of the fluid, outside of the ring, to low pressure, which is in the vortex. So in this vortex, all the way down the fluid, it's low pressure. So any base that I add to that, it's going to stay in that region. So watch, I add the drop. Oh, hold on. You're going to be able to see it in a bit. Am I adding acid? I am. Of course, it's not changing color. Let's try this again. Here we go. I'm going to add drops of base, and you can see that it stays in the center. It tends to stay in that low pressure region. Now, of course, it gets, pulled down to the bottom from the stir bar, and when it hits the stir bar, it gets pushed out along the sides. And so because it's in that low pressure region and it stays in that low pressure region, here, let's add another drop. It's going to stay in that low pressure region. And then once it gets down to the bottom, it gets pushed out along the sides, out the sides and up the top. That's why it happens at the bottom. It's actually easier to see in a flask that doesn't have this hourglass shape. Let's show you with this. This you can see the effect much better. All right, so we're going to try it in this one. So we'll get this going, and we'll answer why it changes colors here in a bit. Right now we're talking about the vortex and why the colors change from the bottom up. So let me go ahead and get it red first. I'm going to get it red since we're at like pH 8 or 9, which is a base. It's easier to see if I get it acidic, so I'm going to add a bunch of acid to try to acidify this. So I'm going to add one drop of acid here. The acid that I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. You can kind of see the effect going on now. I'm also adding it on the edges to try to make this go a little quicker. I'm going to turn the speed down just a bit. Now, again, just like the eye of a hurricane is low pressure, the eye of our vortex is also low pressure. And material stays in low pressure regions. Material moves from high pressure to low pressure. So when I add a drop of base here, it'll make everything turn purple. The base, you can see, tends to stay in the middle. That's the low pressure region. Now, it doesn't stay in the middle forever. It goes down to the bottom, and when it hits the stir bar, it gets pushed out because the stir bar is spinning really fast here. And so that's why the color changes at the bottom first, because the material stays in the low pressure region where I'm adding it, goes down to the bottom, gets pushed out along the sides by the stir bar, and then it kind of rises up to the top. It doesn't stink real bad. The indicator smells a little bit like ethanol, because ethanol is the alcohol that people drink, because that's what they dissolve it in. So that, this mixture smells just a little bit like an alcoholic drink. Now, why does it change colors? If you can artificially make this, can you make it turn a turbine and generate electricity? Gaio, you can't. This stir bar runs on electricity. I don't have any baking soda. I apologize, Mr. Bulldoze. I apologize about that. How can you make the indicator yourself, Mohammed? Mohammed, please answer me if you have access to indicator materials or if it's just something you'd like to do in your kitchen. And what I mean by indicator materials, do you have access to a chemistry lab? You got it, Ashish. The bottom color changing faster is answered by physics. So, Mohammed, you do have access to a chemistry lab. So what you're going to do to try to make the indicator, and you're going to have to play with this because I don't have the exact, Mohammed, I don't have the exact values, but you're going to want to mix together these 4 indicators. You're going to want to mix together some thymol blue, some methyl red, some bromothymol blue, and some phenolphthalein. And, you can just Google on, you can get on a computer, you can just ask, what's a good recipe for a universal indicator? John Doe, John Doe is asking which molecule is heavier, the acid or the base? John, I'm going to answer this question this way. We're not going to talk about which is heavier. We're actually going to talk about which solution, so, the fluid that I'm adding, which fluid is more dense. So, with density, the more dense fluid is going to sink below the less dense fluid. So I'm going to go ahead and acidify this, okay? We're going to stop it. And now, John Doe, I'm going to add the base and watch what happens. All right? So here we go. We're going to add the base and notice what happens. You can totally see that it sinks. See how the fluid sinks? And we're going to add a few drops. I'm going to add like 3 drops. And then I'm just going to let that stay put, and we're going to watch what happens. All right? Maybe I'll add a 4th. I think I'm going to add a 4th. All right, we're going to let that set. All right, and then we'll set up another one. I usually do my live streams on Friday, Saturday, or Sunday, Mexican. We can set this one up while we're waiting this one to do his activity. We'll set this one up so we have something to look at. What am I using? I'm using universal indicator, water, acids, and bases. What is Van Hoff's factor in these experiments? Well, I imagine that the Van Hoff factor of hydrochloric acid is going to be real close to 2. So long, Mexican. How do the colors appear from the indicators? Well, I can tell you how they change color, how they actually... Thank you there, Nanette. Absolutely. Keep science alive. How the materials change color, that has to do with the electronic structure of the molecules in each indicator. So who was the one who asked if the acid or base is more dense? I think we have our answer. Yeah, we have our answer. The base that I added, you can see that's going to be the violet colors that has sunk below the acidic material. Does it affect the density? Ashish, I apologize. I don't understand the question. Something slipped my mind, and there's been quite a few comments coming through, so I'm having a little trouble remember everything. Huddy, thank you for the subscription. The base I'm adding is 20% by weight sodium hydroxide. Here, let's add a drop over here. 20% by weight 20% by weight sodium hydroxide. That's the base I'm using, fish guy. All right, we're going to add a drop of hydrochloric acid, and it goes. 20% by weight, another one here. Isn't that beautiful? I just think it's absolutely beautiful, the different colors that you get. So yeah, it looks like we're at a green color. That's pH 7, so the acid and base, they've been neutralized. Let's add a drop of base. That's going to make this go to the basic end of the color spectrum. And now I'm going to start adding drops of hydrochloric acid. In goes 1 drop. In goes a 2nd drop. Looks like my base is a bit more concentrated. In goes a 3rd drop. Thank you there, Huddy. I agree. In goes a 4th drop. Does the Van Hoff factor affect the density? Ashish, in my understanding, the Van Hoff factor just tells you how many molecule or how many particles you get per how many moles you get dissolved for a mole of substance. That's correct, John Doe. Yep, that's gonna. It's Bernoulli's principle, right? If you have a fast moving fluid, then that fast moving fluid is going to have a low pressure region. We're going to add another drop here. Let's look at our density tower over here. Look at that. You can totally see that the base has dropped below the acid. Let's mix this up. I'm going to mix this one up. We're going to try this again. You got it, John Doe. We got some physics going on here, baby. I'm a physical chemist, so I don't know if that means I'm comfortable in both physics and chemistry, or if it just means that I'm a jack of all trades and master of none. Probably a little more of the latter. I'm a physical chemist that actually worked to get my PhD in a biochemical lab. That fish guy, I could. Unfortunately, I don't have any. I apologize. So right now we're at like a pH 8. When we see that aqua color, we're just slightly basic. Thank you there, Othello. Welcome. We got someone from Germany on board. We're over here. I'm over here in the United States. Ashish, how do I get my subscribers up from scratch? Muhammad, you just keep working at it, buddy. I've been doing this since 2011. I've been at this a long time. Hey, thanks, Danny Ray. I appreciate that. Thank you, Danny Ray. Welcome aboard. Ashish from India. Welcome aboard, Ashish. Adding drops of hydrochloric acid to the flask. Look at that. That was so pretty. Wasn't that a beautiful color shift? Yeah, why don't y'all drop the flag, the emoji flag from where you're from in the chat. I apologize. I don't know them all, but Muhammad was 5 in 2011. That's hilarious. Oh, man. Hey, we got someone from Croatia. Hey, wonderful. Thank you there, Tiny. I appreciate you letting me know that. The beauty of science indeed. The beauty of science indeed. No, Tizzy, not even close. Not even close. Hey, Karen, welcome aboard. Another fellow American. Okay, that's France. Welcome, Dior. I think that's France. Forgive me if it's not. We got someone from Canada. Welcome, Cheeto. Oh, is that Trinidad, Robert? Hey, all right, I got it right. Trinidad and Tobago. Okay, I got that one right. That one I don't know. The blue and yellow one. I apologize. That looks like, is that Nigeria, Huddy? I'm so sorry. Bosnia. Gotcha. Thanks for the help, folks. I don't know them all. I feel, you guys are making me feel ignorant. I don't know my flags. I apologize. But that's okay. I'm going to learn. I'm going to learn. So if you drop them in the chat. A little bit of base over here on the right. Got someone from the U.S., Easton. Metallurgy, material science, PhD student. Come on. That's awesome. Easton, I wish I could get together and learn some stuff from you. That would be fantastic. Now it has turned to geography stream. Sheesh, yes. Have I been to other countries, Danny Ray? I have, but not many. I've been to Canada and Mexico. Unfortunately, that's it. I am embarrassed to say. Tizzy says they're new here, so let me explain what's going on. So we got some of Mr. Paco. We got Rahul from India. I know that flag. I made a short video on the India flag. We did a little experiment that created kind of the India flag. Mr. Paco, I apologize. I do not know where that flag is from. I'm very sorry. But Mr. Paco is studying some biotechnology. That's another one I'd like to get together with. I'd love to talk to all y'all. How do you memorize all organic tests? Tell me about it, Mohammed. No, Tiny, I haven't. I'm embarrassed to say. Ashish, German. Oh, is that just the German? I'm an idiot. Of course, that looks like the Germany flag. Okay, so here we go. So let me explain what's going on here. In each flask, I have some universal indicator. Universal indicator is also known as rainbow indicator. It displays different colors at different pH values. So here we go. Here are the different pH values that you're going to see. The pH just tells you how acidic or basic something is, all right? So here we go. No chocolate, no beer. That's right, Mr. Paco. And I'm so embarrassed. I'm German. My ancestry is mostly German. I should know that. That one was a swing and a miss for sure. Anyway, these are the different colors that you're going to see. So you see this flask over here. It's a violet color. That tells us it's pH 10, which is quite basic. Over here, this flask, that looks like this color here. That's a pH 5, which is slightly acidic. We got someone from Britain. Nice to hear. If you see green, that means it's neutral, which means the acid and base that I have added have been perfectly balanced. We'll get to you a second there, Huddy. So the acid that I'm adding, I'm going to add it to this side over here on the right, is hydrochloric acid. It's the same acid that's found in your stomach. Good night, Ashish. Hope you have a good night. So add a little bit of the acid over here, hydrochloric acid. You can see as you add the acid, the pH drops. Now over here, I'm going to add a base. Yeah, soap can be roughly pH 10. That's right, nom nom. I'm going to add some base over here, and you can see as I add the base, the pH goes up. Okay, so somebody asked me, what's the difference between acid, neutral, and base? So, and you know, strictly speaking, there's a bunch of different ways to define acid, but the way I like best to think about it is an acid is something that donates something that we chemists call a proton. It's an H plus ion. And if you get a bunch of H plus ions in solution, then you've got an acidic solution. The base, on the other hand, that's going to be a substance that accepts H plus ions. You can also think of a base as adding a lot of what are called hydroxide ions to solution. These are different ways to think about them. But I like to think of acids as proton donors. So if you can imagine this thing here is a proton, this red thing, and I'm a molecule that has a hold of this red thing, I might give up a bunch of these, and there's not many in this solution. So if I go and add a bunch of H plus ions to this solution, that's going to make it acidic. If I add the hydroxide ion, to this, it's going to accept all those protons and make water. A neutral solution is going to be a solution in which your concentration of H plus ions and hydroxide ions are equal. What helped me with the memorization parts for my degree? Muhammad, I hate to tell you this, but I have a good memory. So I just would study. And if I would study and spend the time doing it, I spent a heck of a lot of time doing that. It's not like, I just looked at the page and like everything popped into my head. But what I would do is I would read my organic chemistry text and I would do all the problems in the back of the text. And then I would memorize what needed to be memorized. And it spent a lot of time doing that. Oh, thank you there, Danny. Very nice. Can it change only with some drops? Philippe, I apologize. I don't understand the question. XX, what happens if you mix it together? I'm glad you asked. Let's do that. Hey, thanks there, Daddy Ray. Hey, I'm the same way, bud. I'm the same way. You'll hear something and I'll forget it immediately. I didn't used to be that way. Nom nom, glad to hear you got through it. So XXX asks what would happen if you mix them. So what we're going to do is I'm going to go ahead and I'm going to acidify this solution. I want to make sure that my base is not too concentrated over here. So I'm going to try to get this at the low pH range over here. And we're going to try to get this one just at the high pH range over here. I think that might do it. Let's see. And then we're going to mix them. Let's see what happens. What a great suggestion, XXX. Oh, Belgium. Thank you, Mr. Paco. Thank you for... I thought I was... Yeah, for some reason, it didn't quite look like the German flag to me. Okay, here we go. How you doing there, Space Kid? All right, here we go. We've got acid over here at a pH of 3. We got a base over here at pH 10. And XXX asked the wonderful question, what happens if you mix it all together? And that's what we're going to find out next. So bear with me. I got to get a couple droppers, fresh droppers. And then I'm going to stick a flask in the middle and we'll do the experiment. Here we go. Oh, where's a flask? There we go. This will work. This is going to work. You guys can keep me on my toes here. Making me run through my basement lab here. All right. So I'm going to take this cup. We're going to stick it in the middle. Well, I'm going to turn these off. Slide it back just a bit so we can put this here in the middle and do the suggested experiment. XXX suggested we do this. So here we go. I struggle to understand dentine molecules in Chem 2. Can you better explain it? So the dentine molecules. The dentate molecules? So, okay, while I'm doing this, who is this? Hold on a second. What's the name of the person? Zaku. All right, Zaku. So I imagine he or she meant chelating. Is that correct? Like a chelator? And all that means is, if you're familiar with a carboxylate group, which is going to be a COOH group, I'm not sure what you know or what you were taught, so you're going to have to forgive me here. But a COOH group, that's going to have a lot of oxygen there, and there's going to be some lone pairs of electrons on that COOH group. And those oxygens, they can donate a lot of electron density to a metal ion, which is going to have a positive 2 charge. And so you can get molecules with like oxygens that are kind of shaped like this. And then along comes that metal ion, and the electrons on the oxygens like the positive charge on that metal, and so it will grab onto it like that in a chelating effect. Okay. Anyway, I don't know if that's the way the term was being used or not, but if he was talking about chelation, that's what I would wonder if that's what he was talking about. So there you go. There you go. When I mixed the red and the violet, it made green. And that should make sense to us. I cheated a little bit. I had a little bit more of the acid just because I knew what I was doing. When you add these two, they should neutralize, right? So here we go. So, of course, when you add the acid and the base, they're going to neutralize each other. Sorry to hear that there, Zaku. You should give us chemistry professors a little bit of grace. We do have to teach a lot of material in a short amount of time. All right. What else we got out there, folks? Let's turn this back on. Let's get back to doing some of these experiments. Here we go. That was kind of fun. I enjoyed doing that. I always like that experiment. In goes this. In goes this. Okay. Let's add a drop of base over here on the left. Boop. And it goes. Let's add 2 drops of acid over here on the right. Oh, we got a nice little rainbow going on, baby. Come on, man. We got the rainbow. Sultan. Geralt, I have done a BZ reaction. But I don't have the materials here in my basement to do that. Thank you there, Catherine. I appreciate that. Yeah, you can think of it that way, Zaku. You sure can. And it's usually, it's usually like, you know, ions with a lot of oxygen in them. Thank you there, Zaid. I appreciate that. I'm going to try to remember that. Yeah, it's pretty. Oh man, I missed that over there. That was beautiful. All right, I think over here, what I'm going to do, I'm going to turn this off. The acid seems to neutralize significantly faster than the base. That's correct, Bit. Absolutely. The 100% my base is more concentrated. Good eye. Yep. I don't particularly measure these carefully. I use commercial sources for these, and I'm just getting. Oh, you want me to talk about Schrodinger's cat experiment? How you doing there, Gigabean? Schrodinger's cat experiment. It works like this. Here's the idea you have to understand first off with Schrodinger's cat experiment. At its core, quantum processes are random. So there's atoms that we call radioactive. And what that means is the nucleus of the atom is unstable. It falls apart. So there are some atoms that are what we call unstable. All right? No, you're fine, Zaku. So, for example, there's a version of carbon in your very body. In your body, there's a version of carbon. There's not a whole lot of it, but it's in there. There's a version of carbon that is carbon-14. It happens to have 8 neutrons and 6 protons in the nucleus. And the 6 protons is what makes it carbon, all right? But that's an unstable nuclear arrangement. There's too many neutrons, essentially. And so that's going to decay into a different atom. And when it does that, it gives off an electron. All right, so you've got this carbon-14 particle. It's in your body, and there's a bunch of them. And these carbon-14 particles that are in your body, at some point, they decay because they're not stable. And when they decay, they give off electrons. All right, that's the basic idea. But here's the thing. It's an atom, which is a quantum particle, and predicting when a certain carbon-14 atom is going to decay is impossible. Now, in the whole, like if you've got 100 of them, if you've got 100 carbon-14 atoms, in about 5,700 years, about half of them will decay. But you don't know which ones are going to decay. So in the grand scheme of things, you know what's going to happen, but each individual atom, you don't know what's going to happen, all right? So that's the basic idea that you got to understand first to understand Schrodinger's cat experiment. So here's what Schrodinger envisioned. He envisioned then taking an atom of, we'll say carbon-14. Let's make it easier on ourselves. Instead of carbon-14, we'd have to wait too stinking long. We're going to take an atom that has a 50% chance of spitting off an electron in a week, okay? So we've got an atom. We're going to stick it in this flask over here, okay? There's a little atom in this flask over here that's got a 50% chance of decaying and giving off an electron in a week. And we have that atom arranged so that when it gives off that electron, it's going to fire towards a vial, and that vial is full of poison. And if the electron hits the vial, well, then the vial will break and release the poison. And also in that container with the atom and the vial of poison, we're going to stick a cat. And then we're going to seal it all up so that we can't see or can't hear anything on the inside. We can't observe what's going on the inside, all right? So we got this vial. that if the carbon atom releases an electron and it hits the vial, it will break open the vial, release the poison, and kill the cat. And remember, the way we've set up the experiment, it's got a 50% chance, this radioactive atom has a 50% chance of releasing an electron in a week. Okay? So we set up this experiment and we wait a week. All right, now here's the deal. If you take what we call the standard interpretation of quantum mechanics, all right? If you take the standard interpretation of quantum mechanics, after 1 week, if you haven't opened the box, the way the mathematics of quantum mechanics works, before you open the box, you would have to say that there's a 50% chance that the cat is alive, there's a 50% chance that the cat is dead, and more than that, if you take the mathematics of quantum mechanics seriously, then the cat is in a state where it is simultaneously alive and dead at the same time. And that's it. That's the whole idea. And don't forget to feed the cat. Come on, man. And that, Schrodinger came up with this thought experiment to show the absurdity of the theory. That's it. I mean, that's it. So that's the Schrodinger cat experiment. Sorry it took so long, but yep, you got a superposition of states, and what's crazy, folks, is like the experimental evidence. The experimental evidence kind of, at least on the quantum level, it shows that the mathematics are right. The mathematics are right. That doesn't necessarily mean the theory is. What do you mean by that? How can the mathematics of something be right and the theory wrong? Well, if you're familiar with the history of science, think of, the way they used to think all of the planets orbited the Earth, and they had to use a very odd system of circles called orbits and cycles and epicycles in order to try to fit that idea to some mathematics that worked really well. The mathematics worked really well. It's just that the theory was not sound. Anyway. All right, I'm getting near the end of the live here, so y'all know what's coming. At the end of the live, I flip the camera around. Hey, thanks there, Danny. How can 50-50 overlap? Asked John Doe. Yeah, that's a great question, John Doe. How do we say this? It's like this. This is the way you have to view it if you take the mathematics of quantum mechanics seriously. When you open the box, there's a 50% chance that the cat will be alive, and there's a 50% chance that the cat will be dead. And when you open the box and look, it will be one or the other. The deal is, prior to opening the box, if we take the mathematics of quantum mechanics seriously, we have to conclude that the cat is simultaneously dead and alive. So that's kind of the way that you're going to view it. Yeah, Mr. Paco, here's the difference between cis and trans alkanes. Ready? This is cis, and that's trans. And here's your double bond. That's it. That's it. Here, I'll show you one more time. Ready? Here's your double bond, right? If you've got substituents on the same side of the double bond, we call that a cis alkene. If the substituents are on opposite sides of the double bond, we call that a trans alkene. So long there, Danny. Thanks for joining in. All right, a couple more drops, and then we're going to flip this camera around and call it a day. Thanks for joining in. Chirality, Zaid. Yeah, we'll try it, right? My hands, are they identical or not? My left hand and my right hand. Well, they're mirror images of one another. And you can imagine like they're perfect mirror images of one another. They're absolutely identical in every way, except for the fact that they can't be identical because I can't, you know, if I try to make them the same, my right hand has my thumb over here, while my left hand has my thumb over here. No matter how I flip my hands around, I can't change that. That's chirality. Okay, let's turn this thing on. Hello, Jackson. Hello, NRM. Thank you there, Brian. I'm glad you think so. I do work out, but not like I should. All right, let's flip this baby around. Let y'all see this old man in his basement. Talk to y'all for a bit here before we cut off the live. How's everybody doing? A half-dead cat. How you like my shirt? I put this all on special for you today. Yep, I got my glasses on. That's so I can read. I can't, it's really hard to read without without my reading glasses. Is that your math teacher? Hey, thanks there, Bit. Thanks there, Danny Ray. I appreciate that. I don't know what advice you want, Danny. I have no idea what advice you want. Thanks, Noel. I appreciate that. Zaku, that's funny. I'm glad you think so, Zaid. I'm far from 20. I can tell you that. I feel. Well, I think that looks better with those lights on. We're gonna leave those lights on, huh? Yeah. I don't see a whole lot of questions coming through, but I do want to let you all know that I had a great time today, as usual. Y'all asked a lot of great questions. Something I wish I'd have known at 26. Thanks, Noel. I'm no 18-year-old. Something I wish I'd have known at 26. Man, that's pretty deep. Wow, that's hard to answer, man. Hey, Zaku, good talking with you. Go for it, Zaku. Come on, let me know how it goes. That's cool, the white legs. Put lights behind the experiments, you get some pretty cool light shows going. I do put lights behind my experiments there. Let me show you there. Bit. Yep. So I always put lights back there because everything looks a lot prettier when I do. All right. So yeah. I definitely make sure to put backlighting. It really makes things look nice. That's nice, Zaku. What's my next experiment? My next experiment I'm going to post. I think my next video is going to be, I don't know if y'all saw it. I did some experiments with a token that had a particular political figure on it. And I did some experiments on that. And I made another video on that particular token. And I think that's the next experiment that's going out. Actually, Noel. Yeah, I'm still trying to think about how to answer the question. What do I wish I'd have known when I was at Bit. I'm a science person. I love all the science. What's something particularly obscure that fascinates you? A phenomenon, I'll tell you. I've spent since about the year 2005 studying the Diet Coke and Mentos reaction. And I've gone down that rabbit hole, and I've actually published, I think, about 10 papers on the subject. You know, trying to figure out the physics and chemistry behind how it works. So that's pretty obscure, but it fascinates me. What's the biggest word I can think of that's a scientific word? I'd probably pick some organic name, a name of some organic molecule. Those get really long. You got into Princeton, but you don't want to pay for it. Zaid, I thought that Princeton was one of those universities that meets people's financial needs. That's funny, Danny. I see, Zaid. Yeah. Yeah, I don't, Zaid, I had a similar experience. So I got into Columbia when it was time to go to school. Um, and I also got into other institutions. And I don't really think my family could really afford it, but you know, uh, but they weren't getting a whole lot of aid. And I actually chose to go to a smaller school, and I did it, not because of financial reasons. I did it. Thanks, there, John Doe. I did it because I was a wrestler, and the the school that I went to had a much better wrestling team than Columbia, and they were a Division I team. They were a perennial top 20 D1 team. They're not anymore. They're a small state school in Pennsylvania. There's a lot of really good wrestling schools in Pennsylvania, and I wanted to figure out how good of a wrestler I was. And I think, you know what? I can figure out how good I am at academics later on in life if I want to go back to school, which is what I did. Thanks, Noel. I do love doing it, and I love that you're here. So thanks for joining in. Appreciate it. Yeah, I appreciate y'all hanging out, doing some experiments with me. I'm over the 1 hour mark, and I'm running out of steam. Yeah, see why I get. Look at there, huh? Can you tell? Got a little bit of cauliflower here from back in the day. I do, Danny. But they're all grown now. They're all grown. Ooh, Attila, I don't know that. I have done that bit. Hello, pizza. Manda wants an experiment now. Sure, we'll do one more before I call it a day. How's that, huh? We'll do one more. I don't have any grandkids, Noel. Man, do I want some, though. I'm in my basement, ZYX. Put a chicken in. All right, Danny. Here we go. Let's add a little bit of acid here. You can see that red line. We got a little rainbow. There we go. I tell you what, that's a great way to end the live. Thanks for enjoying a little bit of the beauty of science with me today, folks. It's been fun. And I will be checking you out next weekend. Thanks for checking out the beauty of science with me, and we're going to see you next time. All right, everybody? Thanks so much for being here, and I'll see you next weekend. So long.